फर्स्ट टाइम डाउनलोड करने के लिए बोल रही थी, तो सुनाई नहीं दे रहा है। मैं बस टेक्स्ट आते हैं, हमको बता रहे तो कुछ नहीं कर सकते। 3 लाइन में 3 और बता दी थी। और फिर मैंने बस एक बार देखा कि उसको आपको ये तो 3 साल से खड़ा है ना, तो बस कोई टेक कुछ नहीं दे। बाकी मेरा टेक्स्ट वही थे कि इनका वो करना चाहिए और वो करना है। तो फिर से एक्सेप्ट किया है। मेरी रीड है तो उसमें तो उसका नहीं क्यों क्या और उसकी वजह से ऐसा ना
मेरी फर्स्ट की गई है मैं मेरी फर्स्ट की जगह और बड़ा कर
हां राइट वैसे मैंने भी करते हैं लाने के लिए मेरा तो कितना बनाना है
मैथ्स में कर दूसरे सब में अच्छी है साइंस में 36 है और सोशल में 95 है दूसरे से मैथ में
बताने के लिए
5 बताया 5 तो आराम से तो फेल है नहीं फेल नहीं तो आगे लोग गए नहीं ढूंढे रखा
के बाद जाना नहीं ये प्रैक्टिस हमारे स्कूल में अपना फर्स्ट साथ खेल हो रहा है से हम हमारे तो क्लास ही नहीं यूज टू लेकर और दूसरी क्लास में पता है हमारे टीचर तो एक दिन नहीं चाहता कि कल कर देख लेता तो मैंने तो हमारे मेरे साथ चला हो रहा है तो ये चीज का हां फॉलो कर ऑनलाइन स्कूल तो आपको बस हम से एक सीख गाड़ी नहीं हुआ बस अपना हाँ बैठना पड़ेगा फिर हमारा सॉल्व करना पड़ेगा मतलब भी एवरी एमबीबीएस में आऊंगी क्या उसको मेरा डिस्कशन शुरू हो गया आज ट्रेनिंग वो था सब सिलेक्शन में रहना था तो सिलेक्ट हो ही जाऊंगी सबको हरा दिया करेगा हाँ इसके लिए बोला मैंने सब तो मुझे लगा पढ़ाई पे अगर 5 बजे लॉक कर दिया हमारे खाना तो मर्जी है उससे एग्जाम को सही फाइनेंस करके मतलब हमारे वाले पेपर ही उसका के ना ये हमारे को बात है क्योंकि हमारे नेक्स्ट गाइड में चल आते हैं हमारे स्कूल वाले
डेटा मांगे
फिजिक्स केमिस्ट्री बायोलॉजी एक दो है और एक
मोटी क्लास में से कितने फेल
बहुत सारे बच्चे तो नहीं है फिर मतलब तुम्हारी क्लास से तो कम ही है पर चार पाँच
हम लोग के ग्रुप नहीं है क्लास में 12
12 लोग हाँ हमारी प्रीवियस की पूरी क्लास
पहले सब लोग मस्ती करते होंगे
हमारे क्लास में ऊपर मैक्सिमम 2 या 3 लोग फेल होते हैं
एबी का होल स्क्वायर नहीं आता वो लोग पास कैसे होंगे
10 के ऊपर फिर लास्ट में देगा
10 नहीं बोला फिर जितने फेल हुए उससे ऊपर नहीं 6-7 फेल
भाई 40 6 साल हमारे स्कूल में तो बेटा पढ़ेगा मतलब 20 तक नहीं आया हाँ अच्छा ये 20 साल का बड़ा जाते हैं भाई मेरे पास बच्चे भी वैसे आ ही जाते हैं
एक बार गए थे 3 दिन पहले स्नैपचैट स्क्रॉल करते हैं इंस्टा चालू
तो क्या ही होगा
मैं अभी भी गिना सकता हूँ फेलियर होगा मुझे मालूम नहीं होता वो नहीं हमेशा लास्ट टाइम मेरे से पास हुआ नहीं मेरे पीछे में था जैसे बारह नहीं कुछ नहीं आपको तो से फिर और के लिए हमें लेते हैं फिर बाद आप हाँ रिविजन वाली कैसे ये कंफर्म नहीं उसका थोड़ा बहुत का कंफर्म है 6-7 तो मान लेते आपके घर में जाके हाँ पे देखा था तो उसका इसके आगे बार क्या था लड़की इसे संजय का पेपर हाँ तो फायदा नहीं बोला मुझे पर देखा तो सारा पार सारे सारे व्यक्ति को देखते हैं जैसे वेकेशन होता भाई कोई और कुछ बढ़िया क्या उसके बाद से नहीं तो कोई रिश्ता पीछे
Whose model is this? Somebody forgot? You guys don't speak? No idea. Yeah. Say something. Okay. Next. Where did we stop last class? Right. Overall. We had completed force. We did numericals also. Okay, so the next chapter is gravitation. Chapter number 9. What is gravitation?
The force applied by the
Yeah, so it is the gravitational force. Earth attracts every object towards itself with a force which is called gravitation or gravitational force. So, Earth attracts you can say it is observed that Earth attracts every object draw from a certain height. Every object when dropped from vertex and towards itself. Okay. So this force of attraction is called Earth gravity or gravitation. Like any object, when it is left, it is seen that it is falling towards Earth. So the force with which it is attracted is Earth's gravitational force, right? But it is not limited to only Earth, right? If there are any two objects which has mass, they are also attracting each other, right? So it's a universal phenomenon. So that is stated under the law called Newton's universal law of gravity. Let us see what it is. Universal law of gravitation. What is this universal law of gravitation? So, you have any two objects, right, of masses m1 and m2. Let us say they are separated by some distance d, right? So, as per this law, any two objects in the universe attract each other by a mutual force of attraction. So, let's say this is the first body, F12, and this will attract it by F21. Okay, they attract each other. Where magnitude of F12 and F21 is same, but they are in opposite direction, right? So what this universal law of gravitation states is F21 is equal to F21. They are in opposite direction, but their magnitudes are same.
And considering first answer.
Good, you pointed out. Must be Rajvi, right? Oh, Karnava. Okay, so this modulus means magnitude. So although they are in opposite direction, but their value or magnitude is same. Whenever you see the arrow, it means vector. So force is a vector quantity, so it is magnitude as well as direction. Okay. So what this law states is this force is directly proportional to the product of the masses of the two bodies, and it is inversely proportional to the square of distance of separation between them. Okay, this is what it is. So when you combine these two, it becomes F is equal to M1 M2 divided by D square, or F is equal to G M1 M2 by D square. This is the force as per Newton's universal law of gravity. So this M1, M2 are the masses of any two bodies. So it could be Earth and duster. Okay. Right. So you can read the statement given in the book. It states that every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. Okay, that's the law, and this is the mathematical form. Okay, so where G is called universal gravitational constant. It is called universal gravitational constant, and its value is given as G is equal to 6.67 into 10⁻⁻11 Newton meter square per kg square. So in your book, it is rounded off to 6.7. Actually, it is 6.67. Okay. So what is this F? It is the gravitational force between the two bodies. A, force of gravitation. So it is the force due to. So it is force of attraction between objects by virtue of their mass. By virtue of their masses. Okay, gravitation is nothing but it is force of attraction between objects by virtue of their mass. That is force. This is F. Okay. So it is always force of attraction. It is never repulsive. Any two objects which has mass will attract each other. So why it is called universal?
Same all the way.
All in the whole universe, it is applicable. Also, it is independent of the medium. Like these two objects in air will have the same force. Inside liquid also they will have the same force. Okay. So it is independent of the medium in which these masses are present. Okay, that's why it is universal. Clear? Right? So everyone has understood this? Okay. Now let us understand what is the importance of universal law of gravitation. So there are some points given. It explains why objects fall towards the earth. It is because of gravitation. You know? So gravity between what and what? Between Earth's mass and object's mass. Okay. So here this formula will change. So if any object is falling towards Earth, this becomes capital N, this becomes small n. Okay. So the same thing, the value of M1, M2 will change. Likewise, if one object is Earth, the other object is Moon. So this will be mass of Earth, mass of Moon. G remains same. And D becomes distance between Earth and Moon's center. Okay. What is the distance between the centers of the two objects? Okay. So this law explains, this is the importance. Why objects fall towards the Earth? How we are bound to the Earth. If there was no force of gravitation, then if we give a little jerk, and where will we? We'll be flying up. Okay. So it is the force of gravitation which is keeping us bound to the Earth's surface. Then this is also the reason why Moon is revolving around Earth, or why Earth is revolving around sun. Okay. Or why artificial satellites revolve around planets? I mean, why a satellite or even artificial satellite? Okay. So when it refers to satellite, it means about moon. Okay, around Earth. Likewise, various planets have their own local satellites. Okay. It is also the region for tides. What tides have got to do with this?
Gravitation force of the moon.
Yes. So when the moon becomes nearer to some part of the sea, that part of the sea water will rise. That is high tide and low tide. Moon is trying to pull Earth, but liquid is flexible. So Earth is solid, so Earth is not going towards it. Okay, but liquid does. Some part of it. That's why high and low tide in different regions. Okay. So this is what it is. Okay, so any questions here? Now let us discuss what is free fall. So what is free fall? What is free fall? Free fall is free fall is free fall. So when the object is falling only under the influence of Earth's gravity, that's it. Okay, it is only falling due to Earth's gravity, nothing else. Okay, so it's like, what if it is a plane, right? So plane can accelerate. I mean, it can fall faster if it wants to, right? But if you drop anything, then it is under free fall. Okay. So free fall is when object is said to be in a free fall when there is only under Earth's gravity. So when we say gravity, it means force, Earth's gravitational force. Okay. So what is the other property of the free fall? Is it an accelerated motion or a uniform motion? Accelerated, right? Because initially, what was the velocity? 0. Now, at some distance, velocity has risen. It hits with the maximum velocity just before it hits the ground. Okay. So the velocity is continuously increasing during the free fall. So it is an accelerated motion. Under free fall, the free fall the object experiences constant acceleration. So So under free fall, the object experiences constant acceleration. G is equal to 9.8 meter per second throughout. Okay, so its velocity constantly changes.
How is the gravitational force different for that is 9.8 and that is 6?
This is capital G. This is universal gravitational constant. And its unit is Newton meters per kg square. That is meter per second square. This is different quantity. It is acceleration. No, this is a constant appearing in a gravitational force. This is different. When I remove this proportionality, I introduce this constant. We will discuss the relation between capital G and small g. How this figure 9.8 came, we don't know. Do you know it? No, we just told you, use G value as 9.8. Today we will see how this 9.8 comes. Okay? So this is acceleration due to gravity because the force, when this force is acting, then the object is experiencing this acceleration. That's why its velocity is increasing. Whereas this is, both are constant. Its value is 9.8 and its value is 6.7. So see the difference in the unit. This is a different quantity and this is different. So identify the objects by their units. Okay. So what motion is this? Huh? So it is constant or uniformly accelerated motion. Okay. So that is uniformly accelerated. That is free fall. This free fall motion. Uniformly accelerated. Okay. This is what we have done. Okay. Now let's discuss the relation between small g and capital G. Have we written it? Relation between small g and capital G. So now imagine this is Earth and the mass of Earth is capital Earth. Imagine a very small object of mass m, right? It's falling towards the Earth's surface. This is in free fall. Let us say this is Earth's surface, the duster is here. So if I leave it, it will fall. Okay. Now is the distance, what is the distance? Very minimal, very small distance. Okay. So this distance and this distance. What is the distance between the centers? We will just ignore this distance because this is radius of Earth, which is almost 6,400 kilometers. Okay. And this is not even a meter. So this distance can be ignored. So we'll treat this distance between the small object and the center of the Earth is R only. Okay. So what are the forces acting on mass m? Right. So consider a small object of mass m falls near the surface of Earth. Okay. Then by Newton's second law, F is equal to mg, isn't it? Excuse me. Yeah, Arnav hai. Then by Newton's second law, because force is, but as per second law, force is equal to mass into acceleration. And during free fall, the acceleration is g. So mass into, so this is equation 1. Also, by universal law of gravitation, where F is equal to gmn upon r square. This is the radius of Earth. Okay. So where m is mass of Earth, small m is small m is already defined. R is radius of. Okay. So we are ignoring this little distance. So we are taking that as R1. But these forces are on the same object in the same situation. So they got to be same. Right? But F is by equating RHS of 1 and 2. RHS of 1 and 2. What do we get? We get mg is equal to gmn divided by r. So mm will get cancelled. So what do we get? G is equal to gm upon r. Now when you substitute the value of capital G, mass of Earth, and the radius of Earth, you'll get 9.8. Okay, so the calculation is given here. Source this is equal to 6.7 into 10 raised to minus 11. Mass of Earth is 6 into 10 raised to 24. R is 6.4 into 10 raised to 6 square. When you solve and cancel all the units, you get 9.8 meter per second. Okay, these values will be provided to you. Okay. So this capital G is a constant whose value is arrived at by using experimental techniques. All the constants values are obtained by experimental techniques. Is that clear? So today, now we finally know how we get the value of small g.
How did we get the value of big G?
Experimentally. This small g you can calculate using motion in one dimension. Right now velocity is 0, right? You can measure the distance. So from equation of motion, we can find V or A. Using equation of motion, we can find this G. Okay. And now we verify all this. So it is like, what do you call it? Backing up each other. So experimental and theoretical justification is there. Okay. So we study about things in different point in time. Like when it was discovered for the first time, right? But now everything is given to you at one time. That's why there is a sequencing issue. But sometimes you are taught things out of turn, like G तुम बहुत पहले से 9.8 use कर. Today you figured out how we get. Okay, so are we good till here? Now there are some properties of acceleration due to gravity. You can just go through it. We'll just highlight few things. So this is a very important formula, right? If this was mass of moon and this was radius of moon, then you can calculate what is the acceleration due to gravity of moon. So moon's acceleration due to gravity is almost 1/6 of acceleration due to gravity of Earth. The moon's acceleration due to gravity is about 1.6 meter per second square. It's 1/6. Okay, that's why if we go on moon, we'll find that our weight is much less. Okay, is that clear? All right. So open page 23 of your volume. So let's discuss acceleration due to gravity, small g. So what is the definition? It is defined as the acceleration produced in a body under free fall by the gravitational force acting on it. That is acceleration due to any body which is undergoing free fall motion. Whatever acceleration is developed in that body is called what? Acceleration due to gravity. अब जैसे ये बुक को मैं छोड़ दूं, whatever acceleration with which it fell is the acceleration due to Earth's gravity. Okay. So it is denoted by small g. SI unit is meter per second square. So everything you know already. The acceleration due to gravity on the Earth is taken as 9.8 meter per second square. The reason is this. Okay. Now, is G constant at every place on the Earth? No, it's not. It is maximum at the poles, minimum at the equator. You know why? There go. So Earth is not a perfect sphere when it is spinning. So when it is spinning, so it bulges around equator and compresses around the axis. So it becomes like an ellipse. Okay. So let's look at this distance. And this is O and this distance. So OB is greater than OK, right? So what is this force? If this distance increases, this force will be less. Distance in the denominator and how? Square of it. So when the distance increases, any object you keep here, that force will be less. Force is the weight, right? So that will be less. So this is why. Okay. So the Earth's gravity also will be. What is gravity formula? R square. R is that distance. No. So radius is more at the equator than at the poles. So the acceleration due to gravity will be more at pole, less at equator. So as you go from here to here, as you go from pole to equator on the surface of Earth, the gravity value reduces. So it's not same everywhere. Okay, it is constant only at a given place. Okay. Understood? What is the meaning of this statement? G is constant only at a given place, right? It's not same in every geography of Earth. Then what should happen if the object goes much away from the surface of Earth?
Will be out of Earth's axis.
Means the gravity will decrease or increase?
Decrease.
It will decrease because now the distance between the center is increasing. But if the object is close to the surface of Earth, then we can ignore that distance. Okay? So like 10-20 kilometers, the free fall will happen with the same acceleration. But if the distance is comparable to the radius of Earth, okay, if it is significant, right, then you can't ignore. Then the Earth's gravity, as the height increases, it will reduce or decrease. What happens at the surface of Earth? It is maximum. Okay, that value is maximum and constant. What happens below the surface of Earth? As you go deep, it again decreases. No, it again decreases. Why? Because now you have the mass, mass above the body also. Na? Earth's mass is surrounding. It's like this. There is mass here also. Na? Let's say the body is here. Okay, so it is somewhere here. This is the depth. This is the full arm. So there is mass in this region also. No? This region mass. That also is attracting the body towards itself. Then there is mass in this region. Correct? So the force of gravity is due to the mass. So the net result is that as the body goes inside, okay, the gravity reduces. And at center of Earth, the gravity becomes zero. So gravity reduces as you go up, as you go down. Okay, it remains constant only in a region very close to the surface of Earth. So this 9.8 is gonna for distances close to the surface of Earth. And most of our daily life experience will fall in this heading. Okay, so that's what it is. So it is zero at the center of Earth. What about space?
There is no gravity.
No gravity. Earth's gravity is zero in space also. Okay, inside also. All right. So are you finding it interesting? Okay. So two more topics before we complete gravitation part of this chapter. The second part of this chapter includes thrust and pressure. So that we'll do in the next class. Okay. Now we will discuss the equations of motion for a body at a free fall. Any questions here so far? Whatever we have discussed? Huh? No questions? Equations of motion. For a body under a free fall. So Is small g and capital G same or different? What's the difference? What is small g and what is capital G? Yes, what is small g and what is capital G? Capital G is universal gravitational constant and small g is acceleration due to gravity. So for now, just digest this much. Okay. Now, what kind of free fall motion is possible? Yes, this is also free fall. Any motion under gravity, either upward or downward, is under free fall only. Huh? Anything, yeah, but you have only motion in one dimension. Because the plane motion becomes motion in two dimension. Like it is changing height also and ground distance. Vertical as well as ground distance. Then it becomes motion in a plane, two dimension. Okay. So two-dimensional motion in 11th, not in 9. Okay, so the equation of motion for a body under free fall. So for downward motion, will categorize under two types, downward and upward. So downward motion में body falls like this towards the surface. And upward में body falls. Body is thrown up. So what is the difference? We'll compare side by side. So in downward motion, initial velocity is 0. In upward motion, the initial velocity is non-zero. It has some velocity. But when it reaches the top, now it has 0. So what is the conclusion? The velocity at the top height is always 0, whether it is initial or final. Now, the acceleration due to gravity is always downwards. Always. Towards here. Okay. So now here it will have some v. V will be non-zero in this case. Okay. Now what is the sign of acceleration for downward? Is v increasing? Yes. So g will be positive. Okay. Whereas here g will be negative. Motion is upward. This motion is downward. So here g is downward. So g will be negative. These are the only few things that you have to keep in mind. Okay. So how to write equation of motion? Equations of motion are same three equations. So at the top height, what you have is this becomes S becomes H. I have already given you these equations of motion. We have solved numericals already, but this topic is given again. Have you solved numericals on this? No? Acha, in ICS. So S becomes H. The displacement in this case is vertical. And A becomes G. We have to only make these two changes. And the appropriate sign. Okay. So for downward motion, so it will become V is equal to U plus GT. H is equal to UT plus half GT square. Right? And V square minus U square is equal to 2GH. That's it. These are the equations of motion. And depending upon whether the motion is downward or upward, you choose the sign of G. Okay. So sign convention. G is positive for downward motion. J is negative for upward motion. So wherever acceleration due to gravity is causing retardation, it becomes negative. Right? This is it. Now more clarity you will get only when we solve the variables. So sometimes we can modify this equation at maximum height. At maximum height. Maximum height has to be during upward motion. So what happens at maximum height? H is equal to ये होगा V0. तो क्या हो जाएगा? V will be. So H is equal to U square by 2G. ठीक है? So you can actually modify just by making these substitutions. So ये सब भी लिखने की जरूरत नहीं. You can write down at maximum height B is equal to 0 or U equal to V. Depending on whether the motion is upward or downward. Right? Or upward and that's it. Just keep these things in mind and you'll be able to solve all the variables. Okay. With this, we have reached the last part of gravitation portion of this chapter. Is everyone with me or am I going too fast? Huh? Is everybody okay? Let's now discuss what is mass and weight. Can I wipe the board? Just write down. Always write the date. This last date. तो समझ आ रहा है? तो समझ में आ रहा है? जो So is mass and weight same thing or different?
No.
Huh? What is the difference?
It is the force applied on the mass by the gravity.
Yes, by gravity, correct. Whereas what is mass?
Number of molecules.
Yes, it is a measure of the
Massive scale.
measure of the contents of the substance. Okay. So basically, it is. So let's write it.
Measure of its
It is the measure of the matter content you know, given substance. So the basic constituent of matter is atoms and molecules. So it's the measure of that. And what is weight? Weight is force exerted on the substance by Earth's gravity. Earth's gravity. Okay. 2. So it is weight is a force. Okay. What is its SI unit? SI unit of mass is kg.
Okay.
What is the SI unit of weight? Huh? Newton. Because it is force. Unit of force is Newton. And okay. So very big confusion. So when you measure your body weight,
You should say mass.
okay, you actually measure your mass.
But why do we say that the weight is 60 kg?
That's the thing.
It should be 60 Newton if we say that.
So it is 600 Newton. I mean, you have to multiply by G. You actually end up measuring your mass. Okay. So basically, the instrument is measuring weight only, but the value put is divided by G. So it is the scale is divided by G. Understood? So that's why you are able to get your mass. So it's body mass, not body weight. Okay. So that's like what do you call it? It's a common lingo. We mix up mass with weight, but that's not good practice. It is mass. So it is a scalar quantity. Somebody said it is a scalar quantity. So it has only magnitude. Vector quantity. So it has both magnitude and direction. Where is the direction? Downwards or towards the center of Earth. Okay. So direction is towards the center of Earth. 4. It is a
Fixed.
constant for a given object. Mass of the body does not change. Take the body anywhere in the universe. Whatever is the matter content will remain same. It is a constant for a given body. What about weight?
It changes gravitation.
Yes, because G changes. For moon it is different, for Earth it is different. Even on Earth, different geographies, it is different. Okay. So it changes at different places. in different geographies. Due to difference in value of U and U. Value of in those geographies. Yeah. Now, how do you measure mass? Same balance, yes. Measured by beam balance. Or it is also called physical balance. Everybody understand what is beam balance? Huh? What is not saying beam balance? Vendors selling groceries. So both sides, beam. This is horizontal beam. So when it becomes balanced, it becomes completely horizontal. So one side you have slotted weights, the other side will be the groceries or food stuff. Okay. When both are equal, that's when you measure. So it's like mg on this side is equal to mg on this side. Same g on both sides, right? So slotted mass equal to measured mass. Okay, that's all. So measured by beam balance. Beam balance अगर किसी ने नहीं देखा तो तराजू बोलते हैं उसको हिंदी में. After some days, you will see it only in the museum, right? Or in your laboratory. So still some vendors are still using it, but today we have all digital. Just keep it and the digits will come out. Okay. Next is
Same balance.
beam balance. Beam balance. Okay. This is so one more thing is given mass is never zero, right? But G can be zero, like at the center, etc. Then right, mass is never zero. Where can be zero. G equal to okay, we'll continue in the next class.
Just to know एक बार ना तुम लोगों को मैसेजेस बहुत सारा आता है टोटली कंफ्यूज हो जाएंगे अर्जेंट हस्बैंड मैसेजेस that means every Sunday I am giving the test still I am getting messages there are other tests also that is अभ्यास अभ्यास करके अपना एक सिस्टम है अभ्यास का आपको क्वेश्चन पेपर अवेलेबल रहता है यूपी उड़ान इसके बारे में बहुत बार आपको एक्सप्लेन भी किया है ऑनलाइन और ऑफलाइन में भी आगे कंसर्न पर्सन आए थे इधर एक्सप्लेन करेंगे और ये अभ्यास यूटी उड़ान में रहता है। पोर्टल में आपने सबसे ऊपर देखा होगा यूटी उड़ान। यूटी उड़ान में क्लिक करने के लिए आपको फिर से अपना लॉगिन आईडी पासवर्ड रखना है। तो उधर जाके ओपन किया, तुमको अभ्यास का पेपर्स अवेलेबल है। आपको कौन सा टेस्ट मैसेजेस आ जाता है एब्सेंट, उधर देखने का कौन सा टेस्ट आईडी करके वो आईडी फाइंड आउट करो और उधर सर्च ऑप्शन है, उधर डालो कॉपी पेस्ट करके, और वो पेपर आप लोगों को ओपन होता है। टेस्ट पेपर ओपन होने के बाद लिखेंगे पेपर, उसके बाद उसका फोटो निकालेंगे, फोटो निकाल के पीडीएफ में कन्वर्ट करो, ठीक है। उसके बाद आपको फिर से अपलोड करने का, उधर अपलोड करने के लिए चूज फाइल करके ऑप्शन रहता है, चूज फाइल के ऊपर क्लिक करके आप अपलोड करेंगे पेपर, ठीक है। और सब लोग सुन रहे हैं ना, और ये कंपल्सरी करने का, कॉपी नहीं करने का, खुद प्रैक्टिस करके लिखने का, इट इज अ टाइप ऑफ अभ्यास, मतलब सेल्फ स्टडी, ओके। और ये पेपर करेक्शन होके आपको मार्क्स भी मिल जाता है, ठीक है। और अगर आपने टेस्ट नहीं लिखा है तो आपको हर बार एब्सेंट मैसेजेस बढ़ता ही रहेगा, ठीक है। और कुछ दिक्कत है, अच्छा, और एक मेन मतलब इट इज नॉट अपलोडेड थ्रू मोबाइल, मोबाइल से नहीं होता है। आपको अगर करने का है आइदर यू नीड लैपटॉप और डेस्कटॉप, ठीक है। अब एक बार प्रैक्टिस करो ट्राई करो, फिर भी दिक्कत है तो बोलो। एब्सेंट एसएमएस इसी का रहता है, अभ्यास का ज्यादा से ज्यादा। ऐसे भी इसको भी